Today we're going to look at Lesson 5. Your I can statement or learning objective is I can write and graph quadratic functions in standard form. So what we're doing today is very similar to what we did yesterday. We're just looking at the functions or equations in standard form instead of vertex form. But you're still going to look at how to find the vertex, and we'll use that vertex to find the axis of symmetry, the range, the domain, and all of those things. We will still be graphing, so you'll have to use your graphing tools. And I do ask you, as always, to take notes with me, try examples, and see what you can do on your own. And then after the video, if you have questions or need help, I'll be here. You can rejoin the Google Meet, hit Ask My Instructor, or send me an email. Just a reminder, I will be going faster in the video than I would be in person, but remember, you can stop and rewind as you need to and watch it at your own pace. First, you need to know what standard form is. You can see it as an equation or a function, either one, but it's in the form ax squared plus bx plus c. You should remember that. We talked about it when we started factoring quadratic expressions. We talked about what a quadratic expression is. These are no longer expressions. These are equations or functions because they have equal signs. And so we're going to use the pieces from the standard form, the a, the b, and the c, and we can find the vertex. And we can find the x, we can find the y, we can find the axis of symmetry, and the y-intercept. Okay, so when you're given the standard form, you can pick out a, b, and c. To find x, you do this little formula. It's the opposite of b divided by 2a. So the opposite of your b divided by 2 times a. This little equation, when you plug in b and a and simplify, that gives you your axis of symmetry. To find y, you take what you get for x, plug it into the function, and find y. To create your vertex, you plug x and y into an ordered pair or a coordinate point. So we're going to get the vertex just like before. We can find the axis of symmetry from the x coordinate of our vertex. Okay. We also need to know that you can find the y-intercept of the standard form very, very easily. When you're looking for the y-intercept, x equals 0. So we can plug 0 in for x and find y. And that will give us our y-intercept. And you're going to need that sum in today's assignment. You also need to know how to go between the two different forms. So first we're going to look at going from standard form to vertex form. And to do that, you just find the vertex and plug it in. So we're going from this form to this form. Okay? And we can look at an example. So if I give you y equals x squared minus 6x plus 12. Okay, first I'm going to find the vertex. So I know x equals negative b over 2a. Well, the opposite of my b is 6. 2 times a is 1. There we go. So that's 6 over 2, which equals 3. So there's my x. Now to find y, I'm just going to plug 3 in everywhere that there's an x. So that's 3 squared minus 6 times 3 plus 12. Okay, so I plug 3 in and I got 3, so y equals 3. Now I'm going to take my x as 3, my y is 3, so my vertex is 3, 3, and I'm going to put that back into my vertex form. So y equals a is 1, so I don't have to write that down. In parentheses, I have x opposite the x value, so minus 3. That's squared, and then plus my y value, or 3. So that's h, comma, k. All right, and that's my final answer. Let's do one more of these before we move on. So I need x. So x is the opposite of b over 2a. So the opposite of b is negative 4. Then 2 times my a is negative 2. That's negative 4 over negative 4, and that gives me 1. Oh, I forgot to put the squared on here. So sorry, guys. It's not a quadratic if we don't have the squared. All right, now I'm going to put 1 in where x is. So that's y equals negative 2 times 1 squared plus 4 times 1 plus 1. So that gives me negative 2 plus 4 plus 1. And so the answer is 3. So now my vertex is 1, 3. And I can change those to H and K, and I'm going to put those back into my vertex form. So y equals, my A is negative 2. So negative 2 times the quantity x minus 1 squared plus 3. So those are pretty simple. You find x, find y, plug them in to the vertex form, and you've got your equation. Okay, next we're going to go from vertex form to standard form. And the way we do that is just by simplifying. So we're not solving here, but we're just going to simplify the right side of this equation, and it'll turn into our standard form. So here we have y equals 3 times the quantity x minus 2 squared plus 5. So first we have to square this binomial. Now, if you remember the shortcut from the special cases, and I'll make a note here, if you have a plus b squared, that's the same as a squared plus 2ab plus b squared, okay? Or you can do the FOIL method or the double distributive property, whatever you want to do. But if you can recognize this shortcut, it might save you a little bit of time. So x minus 2 squared, so that's going to be x squared, and then 2 times a times b. So 2 times x is 2x times negative 2 is negative 4x. And then negative 2 squared is 4. All right, that's still in parentheses. I bring down my 3 and my plus 5. Now I'm going to distribute the 3 to all three terms. So 3x squared minus 12x plus 12, and then plus 5. I have 3x squared minus 12x plus 17. And that's my standard form. Okay, let's try one more. So again, we need to square this binomial. And if you don't like that shortcut, you can do x plus 4 times the quantity x plus 4, and then do your double distributive property, and it'll work out the same way. So x squared, and then 2ab, so 2x times 4 is 8x, and then plus 16. We have negative 1/2 on the outside, and minus 8. So we're going to distribute that negative 1/2. So that's negative 1/2 x squared minus 4x minus 8, and then minus another 8. And that gives us negative 1/2 x squared minus 4x minus 16. And there's your standard form. Okay, the next thing we're going to do is just look at some examples of your Math Excel problems and work through those so you can see how to do them. I just printed out a preview of your assignment, and I'm just going to work them out this way. I thought that would be easier than me trying to make up the problems and do it a different way. Okay, and so I'll try to go through these as quickly as I can while still giving you all of the information you need. All right, so it says use the vertex and intercepts to sketch the graph, give the equation of the parabola's axis of symmetry, use the graph to determine the domain and the range. So we did all of that stuff yesterday with the vertex form. The only thing different here is it's in standard form. So look at what we're given. You might notice that this is not in the correct order, so I need to change everything around. It's negative x squared plus 6x minus 25. Okay. To do the axis of symmetry, we have to do that x equals negative b over 2a. So that's going to be negative 6 over 2 times negative 1. And that gives us a 3. So our axis of symmetry is x equals 3. Our domain, it's a parabola, so our domain is all real numbers. It says interval notation, so we know that's negative infinity to positive infinity in parentheses. And then it wants the range. So we can do, and I didn't think about this until I just said it, but I think it will want you to graph it first before you find this information. And that's okay. We can do that. So we would still need to find the x. We need to find the y for our vertex. So y equals negative the quantity 3 squared plus 6 times 3 plus 25. So that's negative 9 plus 18 plus 25. And that gives us 34. So our vertex is 3, 34. So I'll plot that point. Oh, did I miss something there? I think that I did. I did plus 25 instead of minus 25. Okay, that is going to make much more sense. Okay, that should be negative 16. I knew that that was not going to look correct. Okay, so now 3, negative 16. So 3 go down to negative 16. All right, now I have that point. The next point I'm going to find is the y-intercept. So for the y-intercept, we just plug a 0 in for x. So that would be negative 0 squared plus 6 times 0 minus 25. All of that cancels out, and that negative 25 is our y-intercept. So on the y, I'm going to go down to negative 25 and plot a point, and we know that both sides of the parabola are the same thing. So I can mirror this on the other side of the vertex. So I was 3 over, so I'm going to go 3 the other direction, and we can make our U shape or our parabola. Okay. Now we have our y value, so we can find our range. So we have a maximum here, so this is the highest value. So that means that our y values are going to be lower. So our y's are going to be less than this quantity. And so if it helps you to think of it as an inequality first, you can. So it's y is going to be less than or equal to negative 16. But we have to do that in interval notation. So that's negative infinity, comma, negative 16 with a bracket. Okay, on the next one, it gives us the quadratic, and it asks us to find the vertex. So you're going to use that x equals negative b over 2a and see what you get. And then you're going to plug that number in for x and see what you get. And so your vertex will be an ordered pair. All right. Number 3, you're going to write that function in vertex form. We did some examples of that already. So you can look at those. So you find the vertex and then put it in that vertex form. Number 4, you're given an equation in standard form, and it wants you to find the vertex, axis of symmetry, maximum or minimum, and then the range. So we'll do this one together. So the vertex, so x is negative b over 2a. So it's the opposite of 4 over 2 times 1. So that's negative 2. We can plug that in and find y. So that's negative 2 squared plus 4 times negative 2 plus 5. That gives us 4 minus 8 plus 5. And so that is negative 4 plus 5 is 1. So our vertex would be negative 2 comma 1. The axis of symmetry is x equals negative 2. It's a positive a, so that means it's going to open up. And so we have a minimum. And the value is just that y value, so it's 1. The range, and it wants an inequality. So the range is going to be greater than 1. Or so y is greater than or equal to 1. Okay, we're going to skip all the way to number 7 because the next few problems in the middle are very similar to the ones that I've already shown you. So here we're going to graph this function. So we're going to use the y-intercept, and we're going to use the vertex. So first, let's find the vertex. So x equals negative b over 2a. So it's negative 6 over 2 times 1. That's negative 3. Our y is, let's see, negative 3 squared plus 6 times negative 3 plus 5. So that's 9 plus, or minus 18 plus 5. It's negative 9 plus 5 is negative 4. So our vertex is negative 3, negative 4. All right, now we need the y-intercept. So our y-intercept is if we plug 0 in for x, those will cancel out, and our y-intercept is 5. So we'll go up to 5. All right, we know that if this is the vertex, we can mirror this point on the other side of it. So I was 3 this way, so I'm going to go 3 this way. And you can make your U shape. Okay, you'll do number 8 the same way. Number 9, it wants you to write this in vertex form. So again, you're going to find X, find Y, and then make your equation. Number 10, I'm just going to talk about real quick. It's giving you a real life application problem, and you're talking about price and revenue. So what you're going to do here is find the vertex. Okay, find the vertex. Your X is going to be the price, and your Y is going to be the revenue. So just find your vertex and plug those numbers in. Okay, number 11 is a little different. We're going to find the y-intercept, and we've done that on a couple other problems, but this one's in vertex form. So we're still going to plug in 0 for x. So that would give us negative 2/3. 0 plus 12 is 12, and we're squaring that. So y equals negative 2/3. 12 squared is 144, so we want negative 2/3 times 144, and that gives us negative 96. So the y-intercept is the point 0, negative 96. All right, number 12, use the vertex and the intercepts to sketch the graph, and then give the equation of the parabola's axis of symmetry. Use the graph to determine the function's domain and range. So this is stuff that we've already done before. So you're going to need to find x, you're going to need to find y. Your axis of symmetry is your x. The domain of a parabola is all real numbers. Make sure you do interval notation. The range, this is positive, so it's open and up. So you'll take your y value and use that for your range. Okay, I'm not going to work through that whole one because we've already done some very similar. And then last, looking at number 14, you're given a function in standard form. You're going to pick out the graph, and then you're going to do the axis of symmetry, the domain, and the range. So very similar to problems that we've looked at before. Find the vertex, okay? Find the y-intercept. That will probably help you. Your y-intercept is 3. And then find your vertex. Find the graph that matches, and then you can use that point, your vertex, for your axis of symmetry, your domain, and your range. Okay? And then you have another one where you're just finding the vertex. So hopefully these examples help you on your Math Excel work. If you need help, please let me know. I would be happy to help you. Have a great day.